yesterday, we're going to quickly look back through what we looked at yesterday. So yesterday, we were doing limit definition of a derivative at a point. So we had a graph as x approaches a, we could look at our slope, right? And it would get closer and closer and closer to being that slope of a tangent line. So in that case, we'll keep moving my A. The A is supposed to stay where it's at. The X approaches the A in this case. So our formula for that, we already have it, but let's write it down. Oh, that's the wrong thing. Don't save that. Get rid of that. Oh, where'd it go? Good gracious. There we go. The formula for that one was, I'm going to call it F prime of A. So it is the derivative of a function at that point. A is going to be the limit as x approaches A of f of x minus f of A all over x minus A, right? And that is our limit definition of a derivative at a point, and we need to have that memorized. But on that last slide that we looked at yesterday, we started to see some of the limitations of this because it only works for a single point. So if I want to find f prime of 2, but I also want to find f prime of 5, and I also want to find f prime of 6.3, I've got to do that process over and over and over again, right? And it is not necessarily the most helpful. Sometimes it would be much easier if I could get like a formula where I could just like get a derivative and then plug in the point afterwards, okay? So there is another formula that is the general limit definition of a derivative that is going to be helpful for us to see. So let me open up this Desmos graph. Okay, it looks pretty similar to what we were doing yesterday. I have a point x, f of x. It's just a point somewhere on the graph. It could be anywhere, right? And then I have another point where I take x and I add some amount h to it, right? So that green line right there is my h. And so the x coordinate of this point would be x plus h. The y coordinate would be x of, let me put another parentheses there. Really? Oh, I did not like that. What did I just do and why did it? Because I hit control. All right, let's not. Let's see it better. Okay. So this is x plus h and f of x plus h, right? So if I want to get this closer and closer and closer to being a tangent line, then I would need to take this point and move it closer and closer and closer to my original point. What happens to my h as I do that? So if you're watching that green line right there, what's happening to h as we go closer and closer and closer here? Shrinking, right? Get closer and closer and closer to being how long? 0, right? So let's think about these 2 points here. I'm trying to get the h out of the way. So my 2 points are x, f of x, and x plus h, f of x plus h. So if I do a slope formula for those, let me turn the pen back on here. Let's see. This is just sort of marking where that h is at. Like noticing that, you know, as this value sort of approaches there. So it's just sort of there for visual, like so you can visually see what's happening with those, with your x value there. So my 2 points that I'm considering in this formula are x, f of x. That was the same as my other formula, right? My 2 points here were x, f of x, and a, f of a. Those are the 2 points that I used for the one that we learned yesterday. My points here are going to be x, f of x, and x plus h, f of x plus h. So if I do a slope formula with those points, then it would be f of x plus h, that's my y-coordinate and my second point, minus f of x, that's the y-coordinate in the first point, over x plus h, which is my x-coordinate in the first point, minus the x right here. But if I want to simplify that down a little bit, is there anything there that cancels? The x's in that denominator are going to cancel. So really this is f of x plus h minus f of x just all over h, right? So this itself is just the slope between those points. But if I take that h value and I make it smaller and smaller and smaller and smaller, then those 2 points get closer to each other. Yes? Oh, sorry. Sorry about that. There we go. For that. So if we do the limit as h approaches 0 here, that's going to give us our derivative. The difference for this is it's not at a single point. So we would call this f prime of x. So it gives us a general rule that then could be used at any point that we want to use this for. So this right here is a different type of limit definition of derivative that we also need to have memorized. This is going to be used when they ask you just for a general derivative, or if they're asking you for multiple points and you don't want to have to do it 6 times. Okay, questions so far? It seems wild and crazy, but it's similar to what we were doing before here. So, find the derivative of f of x equals x squared. For this, if I'm going to use this one didn't tell me at a specific point, right? It just says find the derivative of. It doesn't tell me it's at x equals 3 or x equals 7 or x equals 5. So I have to use the general definition this time. So the derivative of f is going to be called f prime of x, and it is going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's just my rule. This is like, you know, what we had written down before. This is what you're always going to use. But depending on the problem, it may turn into something very different after the first step. Also, just a side note over here, alternate notation. Our textbook uses this, and I'm not sure, but if you chat GPT this, there's a chance it shows up with this. They do f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So if you see this, they're using a delta x instead of an h. Delta x means change in x. H, it's just easier to work with it if it's a single letter. It's less confusing to have that delta x. So most of the time, I don't know that I've seen a delta x on a released AP problem in a long time. Our textbook uses it, but they've been using h's pretty much exclusively on AP material. So I would go with the h here. If you get, like, these problems aren't going to have the delta x built into them. Like back in Unit 1 they did, and I just told you to change them to an h. But I would use that delta x there instead. Hello? He is not here today. He said, he emailed me saying he had a concussion and won't be here. You did say Lucas, right? Yeah, so, all right, okay. No, I don't think so. All right, bye. Okay. So for this, it's a lot like the other problem. I think it's a little harder because you're dealing with more variables. So I think it's a little bit tougher, but it's similar in how you're doing this. And we'll see at the end, it gives you a different type of answer, so we have to do it. Like, there's no getting around doing it this way. The point version, I think, is easier to do, but we can't use it to answer this question. So we have to do it this way. So if I go over to the side, I could find f of x plus h, which means I'm taking the formula wherever that x is, and I'm plugging in x plus h. So this is a pretty simple formula to start with. We just got x plus h squared. And I even like to go ahead and simplify that a little bit before I plug it in, just so I'm not doing so much work in the big fraction where I get things mixed up. And so this, I would just square, double, square. So x squared, and then x times h is xh. Double it, you get 2xh. So plus 2xh, and then square the last h squared. So I will be taking this and plugging it in right here. I will take my just f of x formula, just this formula. I plug it in right here. Make sure you use parentheses for this stuff. It's not going to matter on this problem, but there's lots of problems where it does. And then the bottom's just always h for that. So I've got the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. Again, on this problem, it doesn't matter if you have the parentheses, but on lots of them it does. So put parentheses around each one of those when you plug those in. So on this one, I would distribute the negative. It just makes that a negative x squared, which is very easy to see here. And then whenever we were doing these problems, these delta x problems in Unit 1, when we were just like blindly doing them because they gave us these problems, what we were looking for is all the terms without a h should cancel out, and then you should be able to factor out a h and cancel it. That was sort of the thing that happened every time. Those were limit definition of a derivative problems. You just didn't know what that was yet. You were finding a derivative for those. You just didn't know it. So, so here, this positive x squared and that negative x squared are going to cancel each other out, leaving me with the limit as h approaches 0 of 2xh plus h squared over h. What you should see is everything should have an h with it, so we can factor out a h. So we got 2x plus h over h. Our h's can cancel. So now we're just doing the limit as h approaches 0 of 2x plus h. It's only the h that is approaching 0. So when you do direct substitution here, don't replace your x. You got 2x plus 0, which of course is just 2x. So f prime of x is going to equal 2x. So if I want to know the slope of the graph at 4, I just plug in 4. 2 times 4, 8. So at 4, the slope of the graph is 8. If I want negative 3, I just do 2 times negative 3, it's negative 6, right? This gives me the slope of the line tangent to f at any x value. So I can just plug in and I can find multiple from here. Now there's a shortcut for this that is impossibly easy. It's just like so easy. But we've got to learn it this way right now because if we don't, there's going to be problems that we'll miss because they give you multiple choice problems that are limit definition of a derivative. And if you don't know limit definition of a derivative, you're not going to be able to do it. So we have to learn it this way. There is an easier way coming here. So, in fact, when Hunter was very little, like kindergarten, or maybe even younger, maybe like 3 or 4, I would teach him things that he didn't really know so much, but like it was just impressive to hear him say. So I taught him. I'd be like, Hunter, what's the derivative of x squared? And he would always say 2x. Yeah, he was like little tiny. Ask him at soccer today if he knows the derivative of x squared. See if he still knows it, because we did this a lot when he was little. And when, yeah. I don't know if he remembers like the rule for it. I did teach him the rule one time too, but he might have forgotten that. But I feel like x squared he might remember, because one time my mother-in-law taught his Sunday school class, and his little cousin Maddie was in there, and Maddie was acting like she was supposed to, and Hunter was not. And my mother-in-law was telling him that he needed to be smart like Maddie and behave himself. And he said, does Maddie even know what the derivative of x squared is? To let everyone know that he was smarter than Maddie there. So I wonder if he still remembers it. But I also taught him the Pythagorean theorem, because I wanted him to come in like after school when he got off the bus. And if I had kids here, they'd be like, oh, I don't know. What's the Pythagorean theorem? And Hunter could just like spout it out. But one day after school, he came in and he wrote this on my board. Because we had only like said it out loud, and of course he doesn't know what a square is. So he drew A inside of a square plus B inside of a square equals C inside of a square. So I've been trying to breed him for math greatness. So, like, if you were like the star football player, you got to raise your child, like you live vicariously through them. again. So I've been trying to do that with math, but I don't know. We'll see. We'll see if it works out for me or not. He's doing pretty good. He's doing good for Miss Swisher, but I don't know that he loves it like I do. There, still got Henry. I don't know. He kind of likes it. The other day he had these like big square root problems, like square root of x plus 3 equals 3x minus 4, something like that, and you got like square both sides and solve it. And he wanted to do the whole thing in his head. And he could. He did the whole thing in his head. He could do them in his head. It took him forever to do it in his head because you about have to work like back through it. I could do it much faster writing things down, and I tried to show him that, but he's very stubborn too. So no, I've not done it with Henry like I did with Hunter. You know, Hunter was my only one for so long because there's like a 6-year age gap. So I haven't done it with Henry. I should have. I'm gonna start teaching Henry calculus right now. He doesn't know how to multiply yet, but when he learns how to multiply, I'm gonna start teaching him calculus right now. Because he wouldn't understand calculus clearly, but once you learn how to multiply, I could teach you how to find a derivative. It is that easy. Like you could do some basic derivatives if you just knew how to multiply. You wouldn't understand what in the world you were doing, but you could do it. All right, so, but I'm not telling you yet. If you want to know it, you're going to have to go look it up. You can go look it up and learn the shortcut. It might be a good way to, like, check your answers there. Eventually, I'm going to show you the shortcut, but I'm not doing it yet because once you know the shortcut, there's no way I'm going to get you to write it out the long way and try. So if we have something like this, it's asking us for the general derivative here. So we have to use that formula. F prime of x is going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. You don't have to write that, but I like to write it every time for now, just to reiterate that formula over and over again. So in this case, f of x plus h is a doozy, because you've got to do x plus h to the third power plus 2 times x plus h. These problems are not easy because of just the sheer amount of expansion and stuff that you're going to have to do here. I see to the third power, I really don't want to have to write that 3 times and multiply it. What else could I do? Triangle. So like 1, 1, 1, 2, 1, 1, 3, 3, 1. This 1, 3, 3, 1 is going to be the line that we use. So when we're expanding this, I'm going to have 1, 3, 3, 1. You're going to have x to the third, x squared, x to the first power, and then no x at all with the last one. You're going to go in ascending order with your h's. No h's at all, just a single h, an h squared, and an h cubed. And it's going to be plus signs between all of those. But don't forget, you also have this right here, the 2x plus h. So you got to do plus 2x plus 2h. And I don't believe we have anything that we can combine there. So we got this big long string of stuff here. So we'll be doing the limit as h approaches 0 of, we're going to put all this stuff in parentheses. We've got x to the third plus 3x cubed h plus 3, oh, I'm sorry, that's squared right there. That's not cubed. That's a 2 right there. Plus 3xh squared plus h cubed plus 2x plus 2h. That is just, all of this is just this part right here. So we still have to subtract f of x, which is x to the third plus 2x. So we still have to subtract all of this stuff right here. So that's our f of x. And then all of that is over h. You can see how these get tedious. Like one little thing, it's really easy to mess these up just by multiplying one thing wrong. So whenever we do this, I'm going to just, well, I guess I'll write it out just to make sure I'm clear here. So we have all this stuff. We've got x to the third plus 3x squared h plus 3x h squared plus h cubed plus 2x plus 2h minus x to the third minus 2x. It is okay with me if you don't write out the step that I just wrote, but you got to make sure that you are distributing that negative to everything in that parentheses behind it, because if this 2x right here is not negative, the problem's not going to work. Okay, but the same thing should happen on these problems. Everything you have here that does not have an h should cancel out. So like I've got a positive x to the third here and a negative x to the third over here. So this cancels with that. And then I have got a positive 2x here and a negative 2x here. So this cancels with that. And so the stuff I'm left with in the numerator, every single thing has an h. For the sake of space right here, I'm going to go ahead and factor that h out in this next step. So I'm going to pull an h out front, which means I'm just taking one h away from everything. So I've got 3x squared plus 3xh plus h squared plus 2 all over h. This h right here, this one, it's getting ready to cancel, yes, because we factored this out. So this will cancel with this h right here. And so then if we plug in 0 for our h, we've got 3x squared plus 3x times 0 plus 0 squared plus 2. Basically, anything that still has an h with it is just going to be 0. So we get 3x squared plus 2. This 2h right here was left. And so when you factored the h out, you just had the 2 left. It's this term right here. Because this term, the 2h did not cancel out. Yeah, that is this 2h right here. Okay, questions? Okay, I think this is new notation. We didn't do anything that looks like this the other day, did we? D over dx with some brackets and stuff on the inside means find the derivative of whatever's inside of the brackets here. So it would be like saying f of x equals the square root of x plus 1. Find f prime of x. So that would be the same question. So this is just new notation. Calculus has a lot of different ways of writing sort of the same thing, notation-wise. I don't know all the history of that, but I'm going to say it's partially because it was developed by 2 people at the same time, and they used, Newton and Leibniz definitely used like varying notations there. So we got to do the limit as h approaches 0 of, I'm going to write it every time right now just to reiterate what we're doing, f of x plus h minus f of x all over h. And for this one, I'm actually not going to figure out f of x plus h over to the side because there's not much simplifying to do right there, because you are going to have the limit as h approaches 0. When I plug in x plus h right here for that x, I get the square root of x plus h plus 1. And you can't simplify it any. So that's just it. This part right here, this part right here is your f of x plus h, right? So then I'm going to subtract f of x, which is just the square root of x plus 1. And then on the bottom, I just have an h. And here, of course, this is our f of x in this case. How am I going to solve this one? Conjugate. Got to multiply by the conjugate. Got these square roots. I got to multiply by the conjugate. So I'm going to be multiplying the top by the square root of x plus h plus 1 plus the square root of x plus 1. And I must also multiply the bottom by the square root of x plus h plus 1 plus the square root of x plus 1. So to multiply those together, I will be multiplying here, which will just give me, let's keep our limit notation, let's don't be lazy, we'll get x plus h plus 1. And then the reason we choose the conjugate is because the inside and the outside terms cancel each other out, right? So we're going to multiply here, and we will get positive square root of x plus h plus 1 times square root of x plus h plus 1. But then when we multiply on the inside, we will get negative square root of x plus 1 times square root of x plus h plus 1. Those terms cancel out, and then here you have to be very careful with this. I've got a positive times a negative, which gives me a negative. And then I've got x plus square root of x plus 1 times square root of x plus 1. That's going to give me x plus 1, but it's going to be in parentheses. So that negative gets distributed here. And that will look like this. X plus h plus 1 minus x minus 1 over h times, don't distribute your h here. Like, keep that factored. X plus h plus 1, because we want the h to cancel. Okay, and then here I've got a positive x and a negative x. Those are going to cancel. I've got a positive 1 and a negative 1. Those are going to cancel. And so I'm going to rewrite it just so we're very clear about what's happening here. Now I've got just h over h times the square root of x plus h plus 1 plus the square root of x plus 1 here. What can happen now? H's are going to cancel. Plug in 0 for your h. So you're going to still have a 1 on top because you have to keep something on top there. And then you'll have the square root of x plus 0 plus 1 plus the square root of x plus 1. So that is 1 over the square root of x plus 1 plus the square root of x plus 1. What is the square root of x plus 1 plus the square root of x plus 1? 2. times the square root of x plus 1. And that is our answer. I do know a shortcut rule for that one too. It's not quite as easy as the one before it there. It would take me a little bit of brain power to get that one without writing something down. The other one, super easy. Example 2, third graders could do it by the end of the year. Third graders couldn't do this one by the end of the year. Questions there? All right. Okay, point slope form. I showed this to you the other day, right? These are just review problems, these two right here. Y equals m times x minus x1 plus y1, where here m is our slope and x1, y1 is a point on the graph or on the line. So write me equations. You don't have to simplify them. Just write me equations for those next two. Here's what you should have for that. I went ahead and, like right here, where you have minus -4, I went ahead and changed it to a plus. Some of y'all I saw had minus -4. That's fine. That's accurate. No problem at all with that. There. Any questions here? This is how I want you guys writing the equation of a line. There are other ways, but in my experience grading, this is the best way to do it. Any other way has too much room for error, and unless it tells you you have to, I don't want you to try to simplify. I want you to leave it like this. You could distribute your 4 there and get it into y equals mx plus b form, but unless it tells you that you have to, which it's not going to, don't. Because all you got to do is say something like 4 times 6 is 10, and then you've missed it, even though you had the correct answer. So just leave it if it asks you to do something like this. And you almost for sure are going to get equation of a tangent line problems on the exam. So this will probably be the last one we have time for today. So we're going to write the equation of a line, tangent to f of x equals the square root of x minus 2 at x equals 3. Do I have to use our new rule for this? I do not. I could use either rule for this. Because we are practicing the new rule, I'm going to use it today, just because we're practicing it. But I could use yesterday's rule for this because they're giving it. We're doing this at a point, so it is a little easier. I would probably do that, but just because I want us to practice our new rule a little bit, we're going to use it. So if you're writing an equation of the tangent line, you need 3 things. You need your point, which in this case is going to be f of 3. You need your slope, which is going to be f prime of 3. And you need your equation, which is going to be where you use y equals m times x minus x1 plus y1, right, where you use that point slope form. So if you see equation of a tangent line, these are the things we need. I would do f of 3 first, because you can do it the most easily. So you're going to get square root of 3 minus 2, which is going to give you 1. And that means that 3, 1 is your, specifically, it is what we call the point of tangency. Specifically, it's the point where the tangent line touches the graph, right? It's also just a point on the line there for that. Our f prime, I tell you what, I said I was going to use the other way, but the point formula I think is just easier. And we need f prime of 3, don't we? I just can't I don't even know if I've got time to do it the other way. So let's just do yesterday's formula for this. So that would be the limit as x approaches 3 of f of x minus f of 3 all over x minus 3. Okay, that's yesterday's formula, right? Our f of x minus f of a over x minus a. And so if I do that, I'm going to have the limit as x approaches 3 of the square root of x minus 2. Good news is I already found f of 3. What was it? 1. So minus 1 over x minus 3. How am I going to solve this limit? Multiply by the conjugate. So I'm going to multiply top and bottom by the square root of x minus 2 plus 1. And when I do that, I will get limit as x approaches 3 of, I'll get square root of x minus 2 times square root of x minus 2 is x minus 2. And then I'll get a positive square root of x minus 2, but I'll also get a negative square root of x minus 2. Those middle terms will cancel out. And then I'll just have to do my negative 1 times positive 1, so that'll give me a negative 1. And then on the bottom, I've got x minus 3 times square root of x minus 2 plus 1. Make sure you got parentheses around that x minus 3, because if you don't, it's wrong. There. And so that numerator is x minus 3. And we also have an x minus 3 in the denominator. That will cancel. So we've got the limit as x approaches 3 of 1 over square root of x minus 2 plus 1. We're going to plug in here 1 over square root of 3 minus 2 plus 1. We get 1 over 1 plus 1, which is 1/2. This is my slope. Okay, so I've got my point up here. All right, here's my point. I've got my slope. And the last step is as easy as those two problems that you guys did in seconds before. You're going to do y equals 1/2 x minus 3 plus 1. That's going to be your answer. Okay, questions there? All right, let's see. We missed these last two. Let me look at the questions I had given you. You're definitely, like, my intention was only that you're doing part A today. Part B will be tomorrow. And let me see what we've got here. That's only 5 problems. I feel like that's reasonable. You are not going to be doing the tangent line yet today. That'll be in the assignment tomorrow. So you are just doing like your x plus h minus f of x over h for that. So those are just all asking you for that general derivative. Yeah, just part A. So tonight it is just part A. Tomorrow we'll finish up the last couple examples here, and we will work on the part B part of that assignment. There. There won't be new notes tomorrow. We'll finish these up.